Okay, a second example of a hypergeometric here, a carton of a dozen eggs. So here the total number of things is a dozen, which is 12. Okay, and 5 of these eggs have not been washed. Okay, so the number of things that we're interested in, or successes if you want to call them that, or M or R, is 5. And without looking, the number that is selected also happens to be 5 eggs. Okay, so here M, or call it R if you want, is 5, but also little n is also 5. A random variable x represents the number of eggs that were unwashed from my pick of 5. This is hypergeometric. There is either washed or not washed, only 2 options. The number of reps is limited to 12. There are only 12 eggs. And then here it's dependent. Okay, so because I've got a limited number of eggs to choose from, every time I make a selection, it's also defining the next selection that I can make. Okay, so think about your cards. Originally, you've got a full deck of cards. You pick an ace. Then you don't have 52 cards to pick from anymore. You only have 51. Okay, so here you can see I've got a limited number that I'm choosing from. So each selection will change the probability of the next selection. So this is dependent. Okay, so this should not be a binomial. This should be a hypergeometric. Okay, so this one's saying let's find the probability distribution for x. Okay, the number of unwashed eggs we could pick is 0, is 1, is 2, is 3, is 4, is 5. Any of these options out of the 5 that I pick could be unwashed. Okay, here you can see how to calculate them by hand. Out of the 5 non-washed, choose 0 of them. Then out of the 7 washed, choose 5 of them. Out of the total 12, choose 5 of them, and so forth. Let me show you how to do this in Minitab a little bit quicker to find these options. Okay, here in column 3, I'll just say, maybe number of eggs. Okay, Minitab doesn't like the fact that I used the number sign here, so let me just say number of eggs in words. Okay, and I know it could be 0, 1, 2, 3. What you can do, if you like, is highlight these and go in the corner and drag it if you want. So here, 0 through 5. In column 4, I'll put the probabilities. Okay, so then I'll go to Calc, probability distribution. These are the hypergeometrics. Okay, here I want the exact probabilities, the exact probability of 0, exact probability of 1, and so forth. My total sample size is 12. My number of unwashed eggs is 5, and the number of sample size in this case is also 5. I want to take the options here in column 3. Okay, so column 3, and I'm going to store the probabilities next to it in column 4. Okay, so I could either type in C4 or with my cursor in here just click on the fact I want them to go into C4. As you can see, I've made a probability distribution in Minitab. Here are the probabilities along with the options. You'll find that they are very similar if rounded to what I've got here. B is saying, what's the probability that the person picks exactly 2 unwashed eggs? Okay, so here exactly 2 unwashed eggs is given right here. We've got the probability distribution. We could really answer any question. 2 or more, just add up 2, 3, 4, and 5. Just add these up, okay, or anything you want. C asks about how many do you expect? Okay, so we're going to use the formula for the expected value of a hypergeometric. Okay, just subbing in the values then, we expect about 2 unwashed eggs out of the 5. Okay, what about the dispersion, the standard deviation?